As a framework for analysis, I have used the 4 nested levels for visualization design methodology set out by Tamara Munster in Visualization Analysis and Design, Chapter 4. Considering the domain situation, I've looked at why someone might want to use this dashboard. Then, considering data task abstraction, I've looked at what information is being presented by the dashboard. Considering the visual encoding methodology and the interaction idiom adopted, we've looked at how the information is presented through the dashboard. I have not considered the algorithm as such. This is a small process with a very small data set. It runs fine on the web. In reviewing the dashboard, I apply the expressiveness and effectiveness standards set out by Munster. Does the data presented by the visualizations show the COVID-19 data of interest, and just that? Do the marks and channels used conform to Munster's effectiveness ranks? The main visualization on the dashboard is a set of spark lines. I refer to Edward Tufts' The Visual Display of Quantitative Information in reviewing those. Further, the dashboard uses numbers and tables as key elements in presenting its information. I refer to Tufts again in assessing their value favourably. Tableau Software detail their advice on dashboard design in their current white paper, Visual Analysis Best Practices. A central theme is that when designing a dashboard, it's important to structure it in a way that is accessible to your audience. From an extensive list of considerations and recommendations, I identify some key measures relevant to this dashboard. In a January 2021 Washington Post article, Jacqueline Venimont of Dartmouth College describes the history of dashboards, both generically on and in cars and other physical environments, as well as their current-day computer-based incarnations. She argues that successful dashboards enable their users to understand their situations better, empowering them to make informed decisions affecting their lives and enterprises and activities. For the target audiences of COVID-19 dashboards, this translates to them seeking information on new cases, deaths, hospitalizations, vaccines, that empowers them to determine critical life decisions like, should I stay or go? Should I go to work? Should I get vaccinated? Starting with the why, we look at intent. Why do people go to COVID-19 dashboards at all? What information are they seeking? As an indication, a Google search on COVID dashboards returns 6 billion results. A search on COVID new cases returns 2 billion results. Smaller, but still very large numbers of results are returned for COVID deaths, hospitalizations and vaccinations. These are subjects of great interest. The area of interest here is specifically COVID-19 data, and specifically that in Tennessee. The information used, the data used in the TN COVID data dashboard comes directly from the Tennessee Department of Health. This is data collected in Tennessee directly from clinicians and laboratories. This listing is a subset of the department's data dictionary for the variables used by James May. It shows the variables holding the raw numbers of new cases, deaths, vaccinations, hospitalisation, together with the date on which each of those numbers was effective. It also shows the derived numbers, the rolling averages, the total counts, the positivity rates. This is a very full data set. The James May dashboard did not need to derive any numbers at all. The Tennessee counties map uses luminance to show the relative severity of the various statistics across the Tennessee counties. A tooltip provides more information when hovering across specific counties. The latest values of the key statistics are highlighted. The movement over time of the key statistics are presented as spark lines in the central graphic of the dashboard. A table of the top 5 counties is shown. Labels describe captions and the selected parameters. A key feature on this dashboard are the spark lines, time series lines showing the movement in the different statistics over time. Per Munster, the most effective magnitude channel is the position on a common scale. Time series fit that. Edward Tufts first displayed spark lines in 1983 in his The Visual Display of Quantitative Information. Tufts highlighted that spark lines show nothing but data, perfect data ink ratio. A criticism of this dashboard is that the spark lines do not share a common date axis. They should, to comply with the position on common scale criterion. As well, the spark lines should perhaps be to the left or at least in the centre of the page. The map shows comparative experiences between counties using luminance. As there are 95 counties, the ability to separate using luminance is not very effective, but it is a reasonable way to, in broad terms, see how things are going in nearby counties. The table of key statistics is extremely effective. The numbers are immediately in view for the user. NAFLIC advises not to make the audience work hard to get the information. Tuft says tables are preferable to graphics for many small data sets. Overall, the dashboard has a clean, clear, simple look. White background, uncluttered, Catholic would approve. Using the map, hover over a county to see detail for that county. Click on a county to select that county. Now all statistics relate just to that county. Click on one of the statistics numbers and that will be the statistic displayed in the map and in the top 5 counties table too. So for example, if I click on the positive rate statistic, you will see that positive rate is used on the map and in the top 5 table too. You might notice the closer range of experiences between counties for that positive rate statistic. Select 14-day average from the parameter drop-down, and the time series lines are smoother than their 7-day average equivalents. And if I click on the running totals, the lines are now cumulative curves. Now, select the 7-day moving average parameter again and hover over any of the timelines. It highlights the date for each point as you pass over it. It also shows the values on the other timelines for that same date. Lastly, click on the I for Info button and it hyperlinks to the Tennessee Health Department data source. Using the map to select the county of interest is intuitive to users. It enables swapping between the 95 county-specific datasets. Clicking the key statistic box is intuitive too, swapping the datasets between the 6 alternative statistic sets. Parameter drop-down enables 3 different ways of smoothing numbers across time. Using these 3 filter choices enables 1,710 alternative datasets to be made available to the user. Hovering on the spark line to focus on a specific date enables the alternative statistics to be considered together, assisting a more complex, interrelated understanding. The hover tooltips enrich data viewing by deepening spot-specific detail for the user. Showing the running total statistic for vaccines at the same time as the 7 or 14-day moving averages for the other statistics. Then the audience could actively look for a toppling effect on those statistics, the numbers turning downwards as the cumulative numbers of vaccinated persons grew. That is a key intent question. When will things get better? The data axes of the spark lines should be aligned so that the optimal channel of position on a common scale assists users to grasp corresponding statistics movements. A vertical reference line would add enclosure, separating before and after date ranges, as well as assisting the views of the data line statistics movements. Adding tangential trend lines at the points of the selected common date would assist users to answer their key intent questions. Are things getting better or worse? Using different color hues across the different statistics would assist separability, enabling users to quickly and easily change their focus between different statistics. Parameter drop-down is a 2-click process. A simple radio button option, rather than a drop-down, would keep the alternative parameter options constantly in view. Drop-downs are better when there are many rather than few options. Clear highlight labeling of the selected options, county, date, statistic, would reduce cognitive load on users, avoiding them needing to remember those selections. Summary. I've reviewed the TN COVID data dashboard by James Mack. The audience is Tennessee citizens, assumed to be familiar with basic COVID-19 statistics. The intent is to provide information on what is happening, good or bad. The desired response is to enable those citizens to make life decisions relating to COVID-19. The subject of the dashboard is the Tennessee and COVID-19 information obtained locally by the Tennessee Department of Health. For analysis, I have used the Munster nested levels framework, as well as her expressiveness and effectiveness ranking criteria, as well as dashboard guidelines by NAFLIC and Tableau software. Also edited Tuft on sparklines, numbers and tables and dashboards. I assess the sparklines and the key number displays as very effective. The interactivity is effective and enables access to a very wide-ranging data set. Recommend including vaccine cumulative data alongside the moving averages for the other statistics, correcting the data axes to align across all sparklines. I would add tangential trend lines and make some minor screen positional changes. Overall, my assessment is positive. Thank you for taking the time to watch this presentation.